Well, many times that we have an integral involving the sine and cosine. And of course, there are many ways to deal with integral involved with sine and cosine, depends on the function itself. But there's a very good method that students like it very much. This is the method that let t is equal to tangent half theta. The reason, well, many students like this method because you can change sine cosine into t and change d theta into t. Then the integral with not the trig functions but rather algebraic functions, right? The only thing is that the change to sine, cosine, and d theta is sometimes not easy to memorize. Let me show you a way that it's easy to remember these substitutions. Now, can you draw a triangle? Draw a triangle. Well, this tangent half theta. This angle is a half theta. Half theta, okay. And this is a t, right? This is a t. And this is a 1, yeah. Then the hypotenuse is equal to t squared plus 1, right? T squared plus 1. Then the sine, well, half sine rather, is equal to t over square root 1 plus t squared, right? And the cosine, half pi, is equal to 1 over 1 plus tangent t squared. Then I want a sine, right? Sine theta is equal to twice sine half theta cosine half theta. Okay, this formula, because we frequently use, therefore we well remembered. Then this one is equal to, this is a 2t 1 plus t squared, right? Times 1 over t squared. So this one is equal to 2t, right? 2t over 1 plus. So I have this, sine theta is this. We don't have to memorize the formula, but rather we can derive it from the triangle. And the cosine theta is equal to, is a 2 times the half theta, right? So this is equal to cosine square half theta minus sine half theta. Okay, this is equal to 1 over 1 plus t squared, and sine is this, right? Is minus t squared, right? 1 plus t squared. So this one is equal to sine squared equal to 1 plus, right? This is 1 minus t squared. Okay, this is a sine, this is a cosine. So we don't have to memorize the formula, but rather we can derive it easily, And for d theta, this one, t is equal to tangent half theta. Therefore, half theta is arctangent t, right? Then we differentiate both sides. So this is a half d theta is equal to 1 over t t squared, right? Therefore, d theta is equal to 2 over 1 plus t squared. So we have this. See? We don't have to memorize the formula, but rather we can derive easily from the triangle. Then we have a result that this integral becomes a function of integral of function, this 2t, right? Sine is 2t over this, 2t 1 plus t squared, and this cosine is this, right? 1 plus t squared, 1 plus t squared, and dt is 1 plus t squared over 2, right? And dt. Yeah, forget dt. d theta is good dt. All right. So that new integral, this new integral, will replace this, given integrals, and no more trig functions, just algebraic functions, and we don't have to memorize those kind of substitution, but rather remember the triangle. You can have everything back. Let's have one example, okay? Example. This is an example. D theta 2 plus sine theta. Well, it looks not complicated, but rather it's not easy to do. So if you try this method, then we let that t is equal to tangent half theta. Now, if you remember these substitution, then it's okay. But if you don't remember, you can easily derive from this triangle. Okay. Now, then this becomes right, 2 over 1 plus t squared dt. This is 2 plus, it's a little too small, hard to, this is 1 plus t squared. This is 2t, right? Okay, this is equal. So you have 2 here, you have 2 here, you have 2 here, can be cancelled. Then end up with 1 over 1 plus tangent t squared. This is a 1. This is t over this. So we multiply by 1 plus t squared, both numerator and denominator. So you get 1 here, right? You get 1 here. You get, now you get 1 plus t squared here. This is for this, and plus t. Okay, and dt. All right, this is a result after multiply by 1 plus t squared, both numerator and denominator. And here, this integral, I think you are familiar with complete square, right? Complete the square by complete square. This is equal to t squared plus t2, so this is t plus half square, complete square, right? And this is 1/4. 1/4 becomes 1 now, plus 3/4, 4/4, yeah. Okay, they're equal. And what is next? Next, I know that we try to use this formula, right? D star, right? 1 plus star. We use this formula. This is equal to arctangent star, right? So we try to arrange this one into that form. Now I don't want to use the U business now. Let the U be something that I try to use a direct substitution in your mind. Okay, I want this to become 1. See, the formula is 1, right? So I'll take. Well, what I take? I take 3 was out, right? So this becomes 1. Now, if I take this out, this has to be square, right? According to the formula. So this must be root 3 over 2. Because the after square is this. This is a t plus 1/2. Right? I try to make this satisfy the formula, right? This is square. Okay, this is square. The denominator must be this square root, right? Because after square cancel out. Now, my d star must be this, right? Must be t plus 1/2 over square root 3 over 2. Okay, that one derivatives is equal to dt over this. So I have to cancel with this one. This one must be root 3 over 2, right? Then this is equal. Do you follow? Okay. Then this will be root 3 over 2 over 3 over 4. And this satisfies this formula, right? Arctangent root 3 over 2 t plus 1/2 plus c. Oh, looks messy. Can then simplify this one. This is a 2, right? Yeah. This is a 2. This is a root 3. Okay. And arctangent. This is 2 out. This is 2t, right? Plus 1 root 3 plus c. Yeah. So for this integration, then we have to replace this is back and half t back. This is equal to 2 root 3 arctangent root 3 twice tangent half theta plus 1 plus c. But that's finished for this integral. Okay. Now let's change a little bit that. How about this? How about we make this one as a definite integral? This is 2 plus sine theta, which is from 0 to half pi, for example. Then we here replace the theta from 0 to half pi. Now, also that we can convert theta into t after this. Okay, this becomes right. This is dt, right? We change this one to 2. Now let me omit writing this one, right? This is what? This is when t is equal to tangent half theta. When theta is 0, t is 0, right? When theta is half pi, then tangent quarter pi, t must be what? Equal to 1, right? So after integration, we don't have to go back to theta. We just use t to finish square root 3 2t plus 1 from 0 to 1. Then this is equal to, when t is equal to 1, when t is 1 is what? 3. 3 over root 3 is a root 3. Tangent root 3 is what? Pi over 3, right? When t equal to 0 is 1 over root 3. 1 over 3 arcsine is pi over 6. So this is equal to pi over 6. 2 pi, right? 2 pi 6 over 3. And this is equal to pi 3 over 3. Okay. So that is easier than when you use for this one, when theta is equal to 0 to 2 pi, half pi. Okay, one way or the other, okay, the integral can be, this could be done for that, or indefinite integration becomes this result. So one way or the other, okay, that is application for this kind of integral. For this kind of integral. Okay, this kind of integral becomes this. By knowing that this is a substitution, right? Okay, and you don't have to memorize those things. You can easily derive from the triangle. Okay, that's what I want to say. Thank you for your watching.